Hello, 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 and welcome everyone to today's session on balancing audio systems. Balancing audio systems. My name's Chuck, and we're going to talk a lot about audio stuff. We're going to talk about some calculations. We're going to talk about how to make your room sound good, how to make your system sound good, and some of the basic fundamentals behind what we need to do to make our audio systems pleasurable to listen to. First, before I get going too far, I need to thank our sponsors. Thank you to Kramer, AV Beyond the Box, AV Beyond the Box at Kramer, and to Shure, legendary performance from our guys at Shure. You might even catch a couple Shure microphones here on the set. So, let's get into it. My name's Chuck. I'm one of the senior staff instructors here at Avixa, and I like bacon. So, if you would like to contact me or email me about something, or if we have questions that we didn't quite get to, didn't go over, you can always hit me up on the Twitters at Mad Sound Guy. Please feel free to send me an IM. You could also hit me up on Facebook if you're a Facebook user at Mad Sound Guy. I encourage people to reach out to their AV community and talk, so please feel free to hit me up. If you do, please just introduce yourself, send a message that says, "Hey, I'm Jim. I want to be your friend. I'm an AV guy too." Totally cool. Also on Instagram, and every now and then you'll see funny things of my travels. I'll post on Instagram, Facebook, and Twitter. And of course, you can always reach me at Avixa Profs, AVProfs at avixa.org, or educationmail at avixa.org, educationmail at avixa.org. So if you have any questions that we don't get answered in this session, please feel free to send your questions to education at avixa.org or avprofs at avixa.org, or any one of the Twitter, Facebook, or social media platforms you can find me on. So let's talk about today's agenda. Today, we're going to talk about some of the goals that we're going to be looking for when we balance an audio system. What are the things we're trying to accomplish here? Next thing we're going to look at are some of the levels. To understand about how this thing gets balanced, we have to understand what the levels are and what they mean to us. We have to understand how to read them and how to make them work for us when we're having our system go active. We want to look at some of the methods for setting gain. How do we set the gain? And we're going to go over two methods for setting gain. And we also want to take a look at our equipment specs. This is one of the really important things we're going to look at, our equipment specs. If the equipment isn't designed to fit together, we need to know where to find that. We need to know where to find the specs and how to read those specs to make sure that when we're building a system, when we're putting stuff together, that it's actually meant to work together. So, goals for today. Well, what do we not want our audio system to do? I don't want my audio system to hiss. I don't want noise or distortion. Now, we know a lot of times we walk into a place and we can tell the system's not balanced. I can tell because they turn it on and it goes shh. It just gives us that hissing sound. Sometimes they'll have nothing going through the system, everything's muted, and you still hear that shh. Why does that happen? We're going to see why that happens. Less hiss, less noise, less distortion. With distortion, you can put a signal into your system and have it at a really low level, but still get a lot of that crunchy sound. Sounds like it's going through a distortion pedal or some type of overdrive channel. We don't want that. We're going to see why that happens and how to not have that happen. Better signal to noise ratio. I want my signal above my noise floor by a measurable amount. I want to have a nice 0 dBu. 0 dBu. You're going to hear that a lot today. I want 0. I want my levels at 0. I want 0 dBu above my electronic noise floor. And when my signal comes out of the loudspeakers, I want that signal at least 25 to 30 dB above the noise in the room. I want my acoustic signal 25 to 30 dB above the noise in the room. I also want to be able to meet a performance criteria. If somebody says, "Hey, your audio system needs to do this," I want to make sure I can tell them it does this by the meters, by the numbers. Or if I have to spec an audio system, I want to make sure I know what to give somebody in some type of performance criteria. So, hey, installation company, I want my audio system to be able to perform 30 dB above ambient noise. 30 dB above ambient noise for its normal listening level. So I want to be able to do all that, run my mixer near zero under normal conditions, near zero. We'll take a look what that is. So signal levels. Our signal levels that we're going to be dealing with are expressed in dBs or volts. We could talk about them in either way. We could say it's going to be 0 dBu, plus 4 dBu, or 0.775 volts, 1.23 volts. These are some of the voltages we work with. 0 dBu, this is what I like coming out of my mixer, 0.775 volts, 0 dBu. Plus 4 dBu, you're going to see this a lot. This is what a lot of commercial professional audio equipment puts out, plus 4 dBu. And sometimes you'll see that little plus 4 on the gain knob. It tells you plus 4 dBu is about here, and it says turn it down a little bit below unity. Also, 0 dBV. What does a dBV mean? And negative 10 dBV. Well, a lot of consumer gear is rated for negative 10 dBV, 0.316 volts. What that says is it's going to be below, it's going to come in with its signal below that unity gain. It's going to come in a little bit softer than unity gain. So what I want to do is crank it up a little bit. So if you see unity gain, sometimes you'll see the big U or the little U on your dial. You'll see plus 4 as you turn it down, it says plus 4. And as you turn it up, it says negative 10. That's not meaning plus 4, you're turning it up plus 4. That means that plus 4 piece of gear comes in about right there. Also, microphone levels. Microphone levels. Microphones come in about negative 60 to negative 50 dBu. Negative 60 to negative 50 dBu, or about 1 to 2 millivolts. 1 to 2 millivolts. I know specifically one of the microphones I use right now has it takes about 52 dBu of gain under normal speaking circumstances when you're holding it, just to get it up to unity. When you're talking into it, it takes about negative 50 or about 52 dB of gain to get it up. And we're going to look at how I calculate all that stuff. There is math for all of this. Again, line level, pro audio, 0 dBu to plus 4 dBu. Now, you also want to measure your stuff when you're doing this. If you're working with a piece of equipment, say a professional DVD player, professional Blu-ray player, professional some type of music player, and it has XLR outs and it's a rack ears on it, and it's a lot more expensive, test it. Put a piece of test medium in it. If it's a CD or some type of file that has like a 1K test tone, and put a multimeter on the back of it and see what it's coming out as. You could do this by voltage. If your multimeter has your voltometer, you can go put it to AC voltage and see what it comes out at. And we're going to do that here in a couple minutes with our mixer when we go through our mixer. And it'll be the same steps, the same principles to do that in a DVD player or some professional type of program device. Say a codec. If a codec has a test tone, you could put it out, turn the volume on the codec up, see what it spits out. Consumer, again, negative 10 dBV or 0.316 volts or 316 millivolts, however you like to call it. If I have a consumer piece of gear, same thing. Consumer Blu-ray player, CD player, multimedia player, put that test tone into it and measure it. Measure it on the back end. So input gain. Input gain is the most important setting, and it is the foundation of our entire system. If your input gain is not right, your system is not going to do well. If you have your input gain all the way down and you have to boost your fader all the way up and you have to turn your amps all the way up, that's where you're going to get that room noise coming in. That's that electronic noise floor being raised. So if you think of input gain as the foundation of your system, just like the foundation of the building, if your input gain is solid, you're on concrete. If it's not, you're on sand. And no matter what you do after you build your foundation, you can have the best house ever. But if it's on a foundation of sand, it's going to shift and move and crack. If it's on concrete, it's going to be sturdy. Input gain set up, but not necessarily set up well all the time. So we're going to look to see how we could set our input gain up well. Now, again, let's look at microphones. Some handheld mics, they need about 35 dB minimum minimum to get them to sound. And most of them need a little bit more than that. Some handheld presentation mics, 45 dB. Some gooseneck mics need 45 dB, maybe a little bit more, depending on how far they are. Boundary mics, the flat little mics that you get set on the tables, they're good for conferences. I like to put them in bass drums. They need about 55 dB of gain to get up and to the correct level of what we need to process them, that's 0 dBu. If your mic's further away, you might need 60 plus dB of gain. So depending on where your mic is, what type of microphone it is, will determine how much gain you're going to need. So let's take a look at these microphone specifications. So looking at my microphone specifications, I have the type of mic. It's a dynamic mic. The frequency response. What frequencies is this mic going to pick up? 50 to 15,000 hertz. Pretty good frequency response. What kind of polar pattern? It gives me all the information about this microphone. What I'm really concerned about right now is the sensitivity of this microphone. This particular microphone is negative 54.5 dBV per Pascal. And it says 1 Pascal is 94 dB SPL. 94 dB SPL for 1 Pascal of pressure. So my sensitivity is negative 54.5. So what is that going to tell me? Well, let's look at another spec, my mixer. So I'm looking at my mixer and I'm looking at the specs of the mixer and frequency response 20 to 20. So that means a microphone. I had a frequency response of 50 to 15. Sure, the mixer will handle it. I look at all gain stages. I'm looking at the different sample rates. Oh, look at this. Microphone input gain at minimum is plus 22. Mic in gain max 60 dB. So between negative 38 and plus 22, I have 60 dB of gain that I can give to this microphone. 60 dB available to me. So what does that tell me? Well, let's go through this step by step, soup to nuts. A presenter located 25 meters or 10 inches away from the microphone produces 78 dB SPL. Some people might say, Chuck, how do you know a presenter is going to produce 78 dB SPL? Well, I use the inverse square law. Most people's mouth hole, their voice, at a normal conversational tone is going to produce somewhere between 66 and 70 dB SPL at 1 meter. Again, between 66 and 70 dB SPL for a normal conversational tone at 1 meter. Now, you do have some people who are really soft talkers. You have some loud talkers. So you're going to have to maybe feel out your crowd, feel out your audience, but we've got to start somewhere, so let's start with a norm. 66 dB SPL at 1 meter. So using the inverse square law, if I half that distance, I add 6 dB. So 66 dB SPL at 1 meter, I half that to half a meter, and that is 72 dB SPL. I half that again to a quarter meter. Now I've got 78 dB SPL. This is the kind of thing I do when I'm looking at my microphone measurements, how far my person is from the microphone, how far my talker is from the microphone, at a lectern, at a conference table, in a club, singing to for a rock show. It's all the same. Now, what else do I know? I want to amplify the microphone level signal to line level 0 dBu. There's that 0 dBu again for routing and processing. Most mic preamps will provide around 60 dB of amplification. What do I also know? I have a dynamic mic that sensitivity is 54.5 dBV. How much gain am I going to need? Well, I use this little chart here down at the bottom. Let's go through this little chart. Level at the microphone is 78 dB SPL. That is my talker level at 1/4 meter at the microphone. Microphone reference level, that was at 94 dB SPL, that 1 Pascal. My sensitivity, negative 54.5 dBV. So I have 78 dB SPL, 94 minus 94 dB SPL, plus negative 54.5 dBV. There is a conversion from dBV to dBu, 2.2. It's always the same, 2.2. My output level required is 0 dBu. That's what I want at the back end of my mixer. My preamp gain required for this microphone is going to be about 68.3 dB of preamp. Now, if you remember, The preamp we looked at, the mixer specs said the preamp had 60 dB. So no matter what, if I do it right, I'm going to be a little low. There will be no way other than jamming the microphone in my face to get up to line level. If I reduce that down from a quarter meter to 1/8 of the meter, I add 6 more dB, I'll go down to 62.3, but I have 60 dB of gain. So what does that tell me? I might need a different microphone. So let's look at this microphone specification. Type, condenser mic, frequency response, 20 to 20. Same thing our mixer did. Polar pattern, cardioid, same kind of pickup response as the dynamic. My sensitivity per Pascal on this microphone is 45 dBV. 45 dBV. So what is that going to look like in my calculation? Again, the level at the microphone, 78 dB SPL at that quarter meter. My microphone reference level, 94 dB SPL or 1 Pascal. My sensitivity, negative 45 dBV. That conversion from dBV to dBu, 2.2. My output level required is going to be 0. So how much preamp gain am I going to need? I'm going to need about 58.8 dB of preamp. Hey, what do I know? That fits great within my mixer. My mixer has 60 dB to give. I need 58.8. We are right in there. If I have that microphone that needs 68 and I just can't boost it up to line level, it starts to kind of look like this. I have my noise floor at the bottom. Now the microphone is slightly above the noise floor. Remember we said those microphones are negative 50 to negative 60. That noise floor for your DSP or for your mixing console might only be 70 or 80 dB below 0. If you open up your DSP and you have your level meter, you can actually expand it a good bit and you can check it to see what no signal coming through is. Electrically, I can be somewhere around negative 70, negative 80 dB. So that microphone at negative 60 is pretty close to my noise floor at negative 80. So when I get to the end at the amplifier stage, what I'm doing is boosting that signal up, but I'm also boosting that amplifier up with its noise. So when nothing's going through, that's when you hear the shh. I boosted that amplifier's or the signal's noise floor up in the amplifier. We get the shh, and that is poor signal to noise ratio. What I want is a good signal to noise ratio. I want that microphone to get up to line level, and when that microphone is when it hits the amplifier, I want to amplify that signal. I am going to amplify everything of that signal to include the noise floor. So if I have a big wide signal to noise ratio, if that noise floor is at negative 80 and I have 0 dBu on my microphone, when I raise that entire signal up, I will have microphone sound and no shh. Oops. Here's a little just look between the comparison. I want huge signal to noise. So I'm going to adjust my microphone preamplifiers, any of my mix buses. I want to make sure the preamp on the mic is adjusted first because I want it at 0 before I send it to my mix buses. Any auxiliary sends or sending it to any type of output, effect sends or anything like that. Any compressors or individual equalizers on channels. If I do a insert into a channel, I want to make sure I have enough gain, that I'm sending enough gain into that processor for it to process stuff and then give it back to me. And then I always want to make sure that if I send it out of my mixer, 0 dBu, sending it 0 dBu into an equalizer or into some type of distro, 0 dBu out of that equalizer or processor or distro into my power amp. So the signal I have coming out of my mixer going through anything has the same input and output voltage. I want 0 dBu going into my amplifier. I want 0 dBu going into my amplifier. That's going to allow me to set the right sensitivity on the amplifier assuming I matched my amplifier with my loudspeaker load, and we're going to go over that a little bit later. But then I will have a good clean signal to noise ratio. I won't have to turn my amplifier up way too much, and I will have a nice transparent reproduced audio out of my loudspeaker. So, a couple methods that we're going to use for this. The unity method and the optimization method. Now, personally, I will tell you, I'm a big fan of the unity method. I use it every Friday and Saturday night when I'm doing shows. Real easy to do. Optimization takes a little bit more skill. You have to use a couple pieces more equipment. It will squeeze every last bit of juice you have out of your mixer. So to do this, I'm going to need a tone generator, something that can produce 1K, something that can produce pink noise, and something that can produce 400 hertz. I need these three things. I'm going to need some type of analyzer at the end of my signal chain. I need a voltmeter or a multimeter or something that's going to analyze the electronic signal coming out, the voltage coming out. I'm also going to need an SPL meter. I'm going to need an SPL meter to tell me how much sound pressure I'm getting in my listening area when I adjust my amplifier. So things I need for any of these, some type of tone generator, analyzer to analyze the signal, and an SPL meter an analyzer is going to analyze the electronic signal. The SPL meter is going to analyze the acoustic signal. So for the unity method, I am going to put some type of, and now when we start talking about unity, everything revolves around zero. Everything revolves around 0 dBu. When I put a microphone into that channel, I want to turn up the gain until my talker can bump up around 0 dBu, but it's going to bump up and down around the 0. It's not going to come in like a sine wave. When I put a line level signal into it, I want to make sure that whatever line level signal I'm putting in gets to be 0 at the back end. So it's going to hit my preamp in my mixer, processor, and out of my mixer for distro or EQing or amplification. So to do this, I'm going to set all mixers, trims, faders, cross points, masters, etc. at their 0 or unity setting. It's real important, 0 or unity. Now it says unity, and you're going to see U on a lot of the consoles. The U is the 0, unity gain. I'm going to configure a signal generator to output 1K at 0 dBu or 0.775 volts and connect it to a line level input on the mixer. Now, please connect it to a line level. If you connect a signal generator at 0 dBu, 0.775 volts, and you put it into the mic level, it's going to be really hot, really hot. You're going to back it off, and you might not be able to back it off enough. So make sure it's a line level input. Adjust the input trim until the mixer's output reads 0. So I want to adjust that gain knob. It says the input trim. That's the gain knob until the mixer's output reads 0. So that means I have my fader for that channel at 0. I have my fader for the main mix at 0. And I'm looking at that level meter. Look at that level meter, and I want to adjust the trim until it hits 0. For a line level piece of equipment, if I did what I said to do in step 1, and adjust the trim for unity, and it comes in at +4, I might have to back it off a bit. If it's a piece of line level equipment, professional audio equipment that comes in at +8, I might have to back it off a lot. If it's a piece of consumer gear that comes in, I might have to bump it up like 8 dB, 7.8 dB. So I want to adjust that trim until that meter reads 0 of any line level piece of equipment. With my signal generator, what I'm trying to do right now is calibrate everything for that 0, trying to calibrate my mixer for that 0 to know where I'm at. I want to measure the mixer's output with some type of analyzer, voltmeter, or multimeter. I want to make sure that that mixer at the end of the line, when it's telling me 0, that I have 0.775 volts coming out of that mixer, that it's not too hot, that it's not too low. I want to make sure. Now, they're very touchy. We're going to look at this here in a minute. When I start going through, I'm going to put a camera on my mixer, and we're going to look to see what it does. Using that level, that same level, I want to adjust all the downstream devices in the signal path for the same level. So if I have some type of signal distribution, I want to make sure it's going into that piece of gear, that piece of distribution gear at 0 dBu, coming out of that piece of distribution gear at 0 dBu. If it's not coming out the same as it went in, hopefully I can make some adjustments. If I'm going into an equalizer, after I've gone through this whole thing and I equalize the room, I go back and look at my equalizer. I might have had to take a couple filters out. I might need to actually give it some more EQ gain, and we're going to see how we do that. But right now, let's do this. Let's go to my mixing console and see what we can do about making some gain adjustments. Hey everybody, here I am. So we're going to go right over to the mixing console here, and I'm going to show you by turning the knobs and looking at the meters exactly what's happening when I adjust my gain. All right, let's go do this. All right, so I have my mixing console here. I have my multimeter set up. Turn the multimeter on. Make sure I am on AC voltage or AC sine wave. I also have my noise generator here. Turn my noise generator on. And I'm going to go to, with my noise generator, I'm going to take it over to 1K. Coming in at 0 dBu. I can also show you if I change that, 775 millivolts, 0 dBu. So I can already see I have some signal coming in here. So I'm going to mute this channel for a second. I'm going to bring this up to 0. And if you can see, there's a little U right there, that unity gain. That unity gain is 0 dBu. Nothing yet here. I'm going to unmute this. Bring my fader up. And as you can see, I'm starting to get some voltage in here. Let's unplug this guy here. Starting to get some voltage there. So I am at 0 dBu, what I think is 0 there. And what I think is 0 here. It looks like I'm around -4. So, you know what? I might need some roving camera action here for this guy. So let's get my roving camera. All right, roving camera, good old phone. So, 0 there. 0 there. Now I can see I've got that -4 on my level meter. Well, I see here, see if I could zoom in. I'm a little bit below the unity. I have it set to line level. And I'm coming in here, line level. I'm a little bit below that 0. So let's raise this up to 0 and see what we get. Up to unity, excuse me. I have that 0 on my level. Let's see that again. This mixer trim fader's all the way down. We'll go back to the big shot camera. So I'm going to raise this until that level meter goes up. Let me see if I can zoom in just a touch here. I'm going to raise this until that level meter goes up to 0. And I'm looking at my multimeter. I want around 0.775 volts. Tap it. Tap, tap, taparoo. I'm getting pretty close here. Just touch it. There, 0.77, we're good. Around there, call it like horseshoes and hand grenades. I'm getting pretty close. Pretty close is good. Let's see what 0 says. So I want a true 0. Make sure my faders are set up here right. So what I would want to do is document that 0 dBu, I have 0.790 volts, 790 millivolts. I'm at what I think 0 is on my fader here. Oop, I just touched the fader. Get it back where it's going. And what I think 0 there. Now, I know that it's coming out 0. of 0 dBu, a nice clean 0 dBu out of my mixer. I'd want to do this for every single channel that I was working with. I want to make sure that as I go through every channel of electronic gear I was using, professional audio gear, CD players, again, if you're going computers into a direct box or even just a computer plugging in 1/4 inch, same thing. I want to use that trim knob to get to that 0 level for that channel. This is a unity gain setting. This will make sure I have enough headroom, and this will make sure I have a clean enough signal going down the line. I see we have a question here. From Bill Thompson, is there a reason you're using 0 dBu instead of +4 as my reference? Yes. Okay, it has to do with headroom, Bill. Some of the times my audio systems, I might need 15 to 20 dB of headroom because there's explosions in the program material. If there's some type of movie playing or whatnot, the signal goes up and down and up and down. It's not a straight sine wave. If I use 0, I have enough signal to noise ratio that it's going to be clean, but it also leaves me a good bit of headroom. If we go back here to the mixer, if you look at the fader, these faders have about 10 dB of headroom. I have about 10 dB of headroom here. And back up at the top, I have about 20 before it starts clipping. What I want to make sure is that my signal's not going to get too hot out of the mixer. So downstream devices, if I was going out +4 and my downstream device can only take, say, 20, and my signal goes up to 20, if I'm coming out +4, if I bump my fader up, or if I'm coming out too hot, I might clip that downstream device. Some downstream devices, and this is important that you check your gear, some downstream devices can only take 15 dB on the input. So I want to make sure if that happens, might need to give it a little bit less than 0. Really important that you know the specs of your equipment. I hope that answers your question, Bill. So let's keep kicking with our unity gain structure. Unity gain is going to provide adequate signal to noise ratio for basic audio systems. This is the basic thing we're doing. We're getting it set up, and you have a basic audio system. It's easy. It's fast. Headroom is going to vary from device to device. So the amount of headroom I have out of this mixer, it's going to vary on the clip. Where does it get at the end? Do I have 15 before I clip or 20 before I clip? It's going to vary into the thing I'm going into next, so I have to look at that. If I still want to come out 0 from my mixer, do I have to put a pad in there of a couple dB when I get out if I have stuff that's clipping? Downstream devices may clip before the mixer clips. So I want to make sure that input can handle whatever I'm doing. Most of the time, now truthfully, in my experience, I haven't had a lot of program material that if I balance the input for 0 dB, just like this with 0 dB electronically, I haven't had a lot of program equipment or content that's going to clip my mixer at 20. I might get up to, 15. I might get up to 12 for explosions and things like that. But truthfully speaking, I don't know a lot of things that are going to go straight up 20. If you put in 0, it's going to bob around 0. So let's look at the optimization method. So I'm going to go back and do the same thing, set all the trims for 0, set all the inputs for 0, et cetera, and make sure I'm at 0 on my console, my unity setting. I'm going to configure a signal generator to output 400 hertz. 400 hertz. It's real important that you use 400 hertz, and we'll talk about that when we get to it. 400 at 0 dBu, connect to a line level input of the mixer. I want to connect into O-scope, or for those of you who aren't big fans of lugging around the lunchbox O-scope, you can connect a piezo tweeter to the output. And you're like, Chuck, it's a line level. How come you're connecting a speaker to a line level piece of gear? We're going to take a look at how that works here in a second. Adjust the trim until clipping is indicated on the mixer, and then reduce that level to just under the clip point, And I could truly find the clip point on this mixer. Sometimes the lights are different from the clip point. They go for a little bit of safety, and they start going into the red before it actually clips. I want to listen to that. We're going to listen to that with a piezo tweeter. I want to document that voltage coming out. Document the voltage coming out of that mixer. It's going to be different. I'm squeezing every last bit of preamp juice I can, getting every last bit of signal to noise ratio I can from this mixer. And this is for line level pieces of equipment, or this is for electronic pieces of equipment. I want to connect the piezo to the next device into the signal path and do the same thing. So I want to document the output of the voltage at each device, and if I have to change it to match the mixer's output, I change it. If I have to reduce the gain or increase the gain, I change it to match the mixer's output. So you know what? Let's do this one too. We want to take that signal generator and put 400 hertz in. 400 hertz. Now, a lot of you are going to say, hey, Chuck, there's no way this piezo tweeter can reproduce 400 hertz. You are correct. What it's going to do is when I get to clipping, that sine wave is going to turn into a square wave. When it turns into a square wave, it's going to start producing overtones. It's going to produce harmonics. I want that third level harmonic, not the root, not the octave, but I want the fifth of that harmonic. 400 hertz, an octave above that is 800 hertz. A fifth above that is going to be about 1200 hertz. Right in between the next harmonic, which would be the next octave, 1600 hertz. I want that fit. That's what that piezo tweeter is going to reproduce when it starts to clip and turn into a square wave. So let's do that. Let me turn that up there. Let me take this out a bit so we can see everything. I have my 400 hertz going at 0 dBu. If I turn it up here, I should get about the same 0 dBu. A little hotter than it was before. Let me check this guy. It's a little off. You can see how touchy it is. Now, let me hook this piezo up. Oh, quick question. From, can't see who it is, but there's a quick question about how am I connected in the back here. So let's look at this. I have an XLR connector, 3-pin XLR, wired to the output of this mixer, going to my multimeter. Pin 2 is wired to red and pin 3 is wired to black. 2 to red, 3 to black out of my XLR. So I'm going pins 2 and 3 into here, and that's what's giving me my signal. So I'm going to connect the piezo to that. All right. Thank you to my faithful assistant Erin for kicking on this 57 here. I've got this microphone here, and it's going to listen to the piezo. This microphone is going to listen, and you kind of need to get close so you can hear it. Don't worry, it won't blow your ears out. So I'm going to raise the gain now until I have almost clipping. When I get to that clip, you're going to see this light come on, but then you're going to hear something coming out of the piezo. There's signal going through it right now. Let's listen. Okay, I can hear that piezo. There's my clip light, but I want to go just a little bit more. So I'm at about 5.5 volts right now. If I took it just under the light, 5.3, I get 5.4. I got 5.4 just before my light pops up. 5.6, good steady light. Got a little intermittent light at 5.5. I get up to 7 volts, I can hear it. I can still kind of hear it at, yep, I can kind of hear it. Still kind of hear it. So for safety's sake, and since I have this nice overload light, I'm going to kick it up to about 5.4 volts. All right, so we looked at what we did with the mixer, setting it to unity. We documented that voltage. I had about 5.4 volts that I was looking at that I want to carry forward through. So That's as much gain as I could squeeze out of everything. I'm going to get that same signal, put it into the processors, put it into the distribution, make sure I have the same amount going in as I have coming out. Now, let's talk about some of the pros and cons of our optimization. All right, I am squeezing the maximum signal to noise ratio I can get out of this mixer. That is the most gain I can give before clipping to anything. Each device is going to have the same amount of headroom. So I know everything will have so much headroom at the end, and that's it. I don't have to worry about downstream devices clipping. Everything's going to have the same headroom. The mixer is going to indicate the condition of the system. I'm going to look for that overload light or that VU meter or that level meter. Now, this takes a little bit more time and a little bit more skill to do. And if you're in a noisy environment, it might be hard to hear that piezo ring. Some devices might overload your system. So if you can imagine, I have a hot piece of gear coming in. It's not coming in at 0. It's coming in at +4 or +8, and I have squeezed every last bit of gain I can out of that. That means when that thing goes into its headroom, it's going to clip me. So I might need to put a little bit of a pad on that piece of gear before it gets there. Down the line, if I have pieces of equipment that can't take that hot signal, that means I am going to have to pad them down the line. But if I can get everything working right, all of my electronics coming in the same, giving nice hot signal, I have a huge signal to noise ratio. That means I don't have to put that much stress on my amps. I can de-stress my amps a little bit. So, maximum signal to noise, might overload, takes a little bit more time. Now, let's get to the meat of the matter. Let's get to the microphones. So I want to put my microphones in as well. I want to make sure my microphones have enough signal to noise and can be set up for pretty much any situation they need. Yeah. So setting an individual mic channel. What I need to do is I need to figure out how I can get some type of device to reproduce a human voice. How can I get to reproduce a mouth hole? Well, what I like to do is I like to use a loudspeaker. I want to make this loudspeaker into my mouth hole. So I know between 66 and 70 dB. I'm pretty conservative. I'm going to go on the lower end of 66. So 66 dB SPL out of this thing at 1 meter. And you can see I've got my loudspeaker, got my little handy dandy noise generator. I've got my 5 meter in millimeter increments. Thank you very much to the guys in Helsinki for that. And my SPL meter. SPL meter right here. It's just a regular old Type 2 SPL meter. So at 1 meter, I've measured off 1 meter. Let me go to roving camera here. And you can see I've measured it off. So my SPL is right at about 1 meter. What I'm going to do is I'm going to put some noise into this loudspeaker. Now, I know I'm using this fancy noise generator. You can do this with an iPhone or an Android, anything that will generate noise, an iPod if you have a pink noise track, and a bookshelf computer loudspeaker, say that's all you have, something that has at least a 4-inch or 100 mil driver to reproduce the frequencies that we would need for the human voice. I could put that Android iPhone device into here, and as long as I have good frequency, good hot signal coming out, I'm going to turn this up to where I need it to be, and I'm going to stop. And at that point, I don't make any adjustments to anything. I just turn it on and off. So let's do this here. I have my SPL meter I'm going to turn on. And if I could get my handy assistant over to help me out. So I have my assistant Naren over here. I'm going to turn my SPL meter on. Let me get this the right way. Turn my SPL meter on. or my noise generator on. Pink noise at 0 dBu. This loudspeaker is all the way down, and it's off. So I need to be really quiet when I do this, so I might not talk. So what I'm going to do right now is tell Naren up or down, to turn it up or down, and when he gets to 66, I'm going to say stop. Okay, go ahead and turn it on. We'll push button. All right, now he's not going to touch the volume knob or the sensitivity on the amplifier. He's just going to turn it straight off. We have a good measurement at 66-ish dB SPL, so he's going to turn that straight off. So now we are calibrated. This guy is calibrated for my voice, or for a human voice. He's calibrated for a human voice. So now what I have here is my microphone. So I'm going to go back at what we said, 25.25 of a meter, 250 mil. I'm going to set that back about a quarter meter away from my calibrated mouth hole. And I'm going to turn my gain up until I get 0 dBu. Now this microphone has negative 54.5 dB VSPL. That has 60 dB of amplification. Let's see if we can actually get 0 out of this thing. So, turn on my noise. Here is my microphone channel coming in. Bring it up to 0, unmute it. And I'm going to turn this up, and I am on mic level. I'm going to turn this up and turn this up and turn this up. I'm getting about negative 20. I still need about 20 more dB. Wow, I'm a little light here. And that's, I see some blinking in the 10s, so I'm probably getting into the negative 10 range. Am I on 0 here? So I'm probably somewhere between, I would say between, maybe 12 dB low. Maybe 12 dB low on that. So I have a couple options I could do. One of the things I could do is I could move the microphone closer to the mouth hole. Right now I'm about 250 mil, a quarter meter, or 10 inches. I can half that distance, and that should add about 6 dB onto my mixer. So if you look at my mixer, I'm between, the 4 is blinking every now and then, 7, of course, pink noise is in a sine wave. So I'm getting closer to that. I'm getting closer to that level. But I'm pretty close to my microphone right now. If I half that distance again, I should be able to get 6 more dB. Now about 2.5 inches away, let's see what that does to our mixer. Well, it looks like I made up that 6 dB right to 0. But again, remember, I am peaked. I am peaked out. I can go nowhere else on this gain knob. See if I could zoom in on this gain knob a bit. That guy is all the way up to the rail. That's 60 dB of gain. And I'm still not getting my true zero out. So that kind of shows us the importance of picking the right gear to go with the equipment for the right application. What would be better, instead of that negative 54.5 dBV dynamic mic, if we used a condenser mic that had a 45 dBV sensitivity. Now that we did that with our microphone, we balanced out that channel. We can look at our equalizer a bit. So we set up our microphone, set up our amp, set up our speakers, and don't worry, we're going to go over how to set up our amplifier and how to match it to our loudspeakers. That's all part of balancing this system electronically. We have our EQ. Now we're going to run some pink noise through the room, do a little spectral balance action, and as you can see, some of the faders have to move to get that signal to match up nicely in our room. Every room is going to be different, so I had to put in some filters here, but that's going to take my overall output. These filters are going to reduce the voltage of my overall output. So what I'm going to have to do is use that makeup gain that's here on the EQ. That's what this makeup gain is for, is to make sure we can still get out to the same level that we had coming in. We have more on how to EQ the room. If you read our we're having a lot of stuff now on spectral balance, whole standard, I believe, on spectral balance. More to come on EQing the room a little bit later. Let's finish setting it up electronically. So EQ is going to remove energy from the spectrum, configure the generator, pink noise at 0 dBu, connect it to the line level input of the mixer. Get some sound in the room, EQ the room, make sure there's enough audio in the room, 25 to 30 dB above ambient. Adjust our EQ, check it electronically again, makeup gain, adjust the EQ, makeup gain. You might have to do it a couple times. This process is a little iterative. The more you do it, the quicker you get at it. All right. Same thing for setting gain after your devices, setting the signal after your devices, to setting it on your mixer. Adjust the input to read 0 at the output of the mixer, using reference level before, connect an analyzer to the output of the EQ, increase the gain in the EQ until it reaches reference level. Boom, easy done. Optimization, same thing after the EQ as we did out of the mixer. Just connect that piezo, just like I did with an XLR with some type of 1/4 inch to the piezo, and little clips on the piezo until you hear that, and then you're good to go. So what haven't we talked about? The last thing we have to talk about is the amplifier and the loudspeakers. Now, a lot of people will see this and be like, oh yeah, let's just turn the watt knob up and get more watts to our loudspeakers. That's not how this works. That's not how any of this works. What we have to do is figure out exactly how many watts do we need before we even buy this amplifier. Then we purchase a correct amplifier matched with the speakers, matched to the room, and we can properly set the amp for the loudspeakers in the listening area. So what we need to do is find the EPR, the electrical power required at the loudspeaker. To do this, we need a few things. I need the target listening level in the room, the amount of headroom required, the loudspeaker sensitivity, and that's going to be in the loudspeaker spec sheets, and the distance from the loudspeakers to my ear hole, right to my listener. So I'm going to take my SPL meter and I'm going to determine the target desired SPL for my audio system. I want to measure the ambient noise of my space first. So I want to set my SPL meter to A-weighted slow, and my ambient noise is going to tell me what my noise floor is acoustically in that room. Then I want to make sure that I have 25 to 30 dB SPL above ambient noise. Again, I'm very conservative with my measurements, so I want 30 dB SPL above ambient noise. 30 dB above ambient noise. So measure the room's SPL, and figure out what my ambient is. Then I can figure out what my loudspeakers need to produce. So, all right, here I am again with the same SPL meter. I'm going to turn it on. I am set it to A weighted, low. And now, since sound is energy, it's going to bounce around this room as I talk. As I talk, the energy just doesn't come out of my mouth and die. It bounces around all the surfaces. There's a bunch of different reflections. And it's going to bounce around more than you can hear when it gets below the noise floor or when it starts dying out. But it's still going to be sensitive to the meter. So what I need to do is I need to be silent and watch the meter rise and fall, watch the meter rise and fall, and it's going to fall, and then it's going to stop. Go up a couple, go down a couple. And when I say a couple, I mean like a tenth of a dB, a tenth of a tenth. So let's watch to see what the meter does. All right, so we're about 42, 43 dB SPL ambient noise. When we start talking about calculations, just for ease of math, for me, because I'm doing this on the fly, I'm going to call it 45. Let's just call it 45. 45 dB SPL ambient noise. Now, this room is a little noisy. I've got an air conditioner that just kicked on. I've got racks that are blowing fans, so it's a little bit noisy. You might find your room's about 35 to 40 dB SPL, 45 dB SPL. If you start getting above 45 dB SPL, it's going to be a little sketch on your system. Now, this is for an empty, quiet room. Got a question from Stavros. Stavros, how many dBs do you have to account for when measuring an empty room versus a full room, a room full of people? Is there an approximate number? There's really not an approximate number. It's going to depend on the room, on the environment, on the crowd that you're doing. What I do as a professional, if I'm going to do a room I haven't done before, I like to go maybe the week early if I can, or a few days early. And I always have my handy SPL meter on my phone with my measurement mic. Very important. I use a calibrated measurement mic. And I will go to the venue and just kind of check it out. And if there's a big crowd, I want to measure it right after sound check before the band goes on, maybe in between sets while people are drinking and having a good time. Or if it's a venue that's very, very quiet, I'm doing sound for a string quartet in a nice, beautiful opera house. I want to measure that and make sure that the sound coming out is going to be appropriate for the listening level, 25 to 30 dB above. So if there's a big room full of people, or if it's a festival, hopefully you've gone to a festival before. And if you go to a festival and you haven't taken any measurements, give it a shot. A little bit of knowledge in your brain housing group might help in the future. So hope that answers your question, Stavros. If you want to talk about it a little bit more, just shoot me an email at avprofs@avixa.org or education@avixa.org, and we'll hook you right up. Cool. So now that we've determined what our ambient noise is, we're going to call it 45. We're going to shoot for 25 to 30 above. I'm going to call it 75. I want to shoot for about 75. So now that we have that, we have to determine what kind of headroom we need. What kind of headroom we need. And I'm not talking max headroom. I'm talking electrical headroom. How do I figure that out? Well, I have a couple different types of things I'm going to be amplifying. Speech and program. And when I say program, I mean some electronic type music, dance music, or some video codec, or some movies, or CDs or whatnot. So for headroom that I need above my regular noise, or above my regular level, I want 10 dB for speech, 20 dB for program. So that tells me if my voice is coming in around 0, it's just bouncing around 0 like the pink noise, and I get really loud and excited, that I have some room there to get really loud and excited. Same thing with program. If there's a quiet passage in a movie and then they have explosions, you want to make sure that the system can handle those explosions without going into clipping or distortion. I know there's been times where I've listened to systems that weren't set up right, and the explosion would be distorted because they wanted to boost the level of the romantic scene where the guy is talking sweetly to the woman, and all that. It's apparent. It doesn't happen very often because we don't have a lot of big explosions, but it will be apparent when you have those changes. So 10 dB for speech, 20 dB for program. All right, so now that we have our headroom, the next thing we want to look at is loudspeaker sensitivity. And I want to look at the spec sheet of a loudspeaker. Loudspeaker sensitivity is going to be the measure of sound pressure level a loudspeaker puts out at a specific distance for a specific input signal. So I am going to put a specific signal into that loudspeaker and take a measurement at a certain distance, because remember, sound differs with distance. So if I put so much energy into a loudspeaker at so much of a different distance, what is that level? So here's my loudspeaker specifications. Frequency response, cool, 79 hertz to 21K. Frequency range, 60 hertz to 24K. Negative 10 dB, that's cool. What I'm really looking for is this one right here. System sensitivity, loudspeaker sensitivity. That's 91 dB, 1 watt, and that's usually at 1 meter. Oh, yep, 1 watt, 1 meter. So if I put a test tone, usually 1K or 2K, into this loudspeaker, and I put a SPL meter at 1 meter with 1 watt of power, this is the SPL I get, 91 dB. So now that I know my loudspeaker sensitivity, I need to figure out the distance from my loudspeaker to my ear hole. Pretty easy. So this gentleman here is seated, and the loudspeaker is above his head. So let's say in this room, the loudspeaker is 10 feet above the ground. It's in the ceiling at 10 feet, 3 meters. Ish, 3-ish meters. He is seated, and his ear height is about 4 feet or 1.2 meters above the ground. So 4 feet, 10 feet on the loudspeaker. That leaves a distance from the loudspeaker to my ear hole at 6 feet. If he was standing, say he was standing, his ear hole would probably be somewhere around 5 feet, depending on the height of his, it's going to change. It's going to vary based on your audience. But let's say my ear holes are about 5 feet, 60 inches off the deck, 1.6 meters. It's going to be different. I would have 5 feet by 6 feet in between my ear holes. So you want to know if the audience is going to be standing or sitting, how high the ceiling is going to be. That'll give you your distance from loudspeaker to ear hole. So now that I have all this, I have my Target SPL, headroom required, loudspeaker sensitivity, distance from the loudspeaker to the listener. I can do my EPR calculation. Whoa, holy cow, look at that thing. Amount of electrical power required at the loudspeaker, sound pressure level required at D2, headroom required, loudspeaker sensitivity at 3.28 feet or 1 meter, distance from the loudspeaker to the furthest listener, and the distance reference value, that 1 meter. That 1 meter was our reference value, and the wattage reference value. Assume 1 unless otherwise noted. Unless that spec says I put 2 watts into it, we're going to go with 1. 1 watt, 1 meter. So let's see here. Well, my target listening level was 75 dB SPL. That was that ambient noise I took of 45-ish. We were about 42. I'm going to call it 45 for ease of math. Plus 30 dB, so I had 25 to 30 dB, and I said I was conservative, so I'm doing 30 dB above ambient, 75 dB SPL. I'm going to put program material into it, so I need that 20 dB of headroom. My loudspeaker was 91 dB, 1 watt, 1 meter. The ceiling height, D2, was 10 feet or 3 meters, minus my ear hole height, seated at 4 feet or 1.2 meters. Then I have my reference value. That was that 1 watt or 3.28 or 1 meter, or 3.28 feet. My wattage reference value of 1 watt, 1 watt, 1 meter. So let's do this calculation. If you have your calculators, you can follow along. So EPR equals 10 to the power of all that stuff divided by 10 multiplied by 1. So EPR 10 to the power of 75 dB for my listening level required, 20 dB for my headroom, minus 91 dB loudspeaker sensitivity, plus finding that distance. I had that 6 feet, right? 6 feet was that distance of my 4-foot ear hole to the 10-foot ceiling, divided by my reference value, 1 meter or 3.28 feet. So 75 plus 20 is 95. Negative 91 leaves me with 4. 20 log times the D2 divided by reference. 20 log D2 divided by reference is going to be 5.24. So I have 4 dB plus 5.24. That's going to equal 9.24 divided by 10 is going to equal 0.924. 10 to the power of 0.924 is 8.39 multiplied by 1 gives me 8.39 watts. I'm going to need 8.39 watts of power to get to my required listening level of 75 dB SPL with 20 dB of headroom at 6 feet from my loudspeaker to my ear hole with a loudspeaker of 91 dB SPL 1 watt 1 meter sensitivity, 8.39 watts. So if I had 10 of these loudspeakers in the room, I would need 83.9 watts of power, roughly 84 watts of power. So doing my amplifier calculations of 1.5 times what I actually need to rate my amplifier. So when if I blast it or go into excessive headroom or when it turns on and it spikes, I want to make sure I have a little bit of safety in there. So 8.84 watts times 1.5. Well, let's see. I just do 84 divided by 2 is 42. 42 times 3 is 126. So I need at least a 126 watt amplifier. So if I look at my amplifier, if I am putting a 0 dBu signal into my amplifier, it's going to give me 126 watts. That's the amplifier I bought, 126 watt amplifier. 0 dBu in, it's going to give me 126 watts. I don't need 126 watts. I need 84 watts. So I'm going to turn that amplifier down. The sensitivity on that input, I'm going to turn down. I'm going to turn down enough that it gives me the SPL I need for that room. So let's look at this and how we do this on our amplifier. All right, you can see I have my loudspeaker set up. This is a powered loudspeaker, so the amplifier is in the back, but there's no difference. There's no change in how we do this from a separate amplifier with the loudspeaker than there is in a powered loudspeaker. Now, what I'm going to do is come over to my mixer, turn back on my noise generator, and I'm going to go to pink noise. Now I know it says negative 2 dBu. That's the highest this pink noise goes up to. I turn it up. I can't go up anymore. I go down, but I can't go up. But that's kind of irrelevant because what I'm going to do with this guy is I'm going to make sure I have 0 dBu coming out here. You can hear it in my piezo. Let me disconnect this piezo. And again, I'm all the way down, but I'm coming out pretty hot. So I'm going to adjust this until I have a nice 0. And when I say bobbing around, it just bobs around here. It's like the human voice. Pink noise is more like the human voice than the sine wave. So I've got a good 0 coming in there. So next thing I need to do, I have that 0 coming out to my, I want a good 0. Give me a good 0. That is a good 0. That's a good boy. So next thing I want to do is go to my amplifier. All right. On my amplifier, First thing I want to do, it's all the way down. I want to turn it on. Next thing I want to do is I want to adjust the gain on my amplifier. So for this, I'm going to need my trusty assistant again, and I'm going to need our old PAL SPL meter, and we're going to go for 75 dB SPL. So we're going to take the measurement right here in our listening area, and we're going to go for 75 dB SPL, and we're going to go A-weighted slow. Trusty assistant is going to hold that up, and I'm going to increase the audio until it sounds appropriate in our area. All right, that's good. We got pretty close to 75 dB SPL. Thank you, Noreen. Got pretty close to 75 dBL in our listening area. Now, the next thing I want to do is test out that microphone that we calibrated before for 0 dBU for my mouth hole, right? I want to make sure that microphone is not going to feed back into my loud system, and when I talk on it, I can be heard clean and crisp and have a nice transparent audio system. And my listening area should have a good experience, kind of like we're 1 meter away. Hey. So let's go to my microphone and make sure my microphone's on. I don't know if little whine there. My microphone was on. I'm getting a little tiny bit of feedback. I'm probably a little bit hot for my voice. Check, testing. Oh yeah, let's go to the mixer here. When I calibrated it with my calibrated voice, it was about 0. But as you can see now, I'm a little hot because my voice is kind of boomy. I'm used to talking a lot, and I'm a pretty loud guy, so now I've taken it back down to where my mixer's bouncing around 0, checking 1, 2, test 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, testing 1, 2, 3. I've got 0 here, 0 there, 0 coming out. I wonder what my voltmeter says. Checking 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, testing 1, 2, testing 1, 2, 3. It's about what I would expect. So bouncing around 0 here. I'm not going to touch this guy anymore. I am in my listening area. I am talking on my microphone, and I'm at a pretty good level. How's that sound, Noreen? Noreen's giving me the nod. He's giving me the thumbs up that it sounds pretty good. And this is a cool thing. I'm at about a half meter before I sense any kind of a loop or feedback. So that is soup to nuts. I set my loudspeaker up for my listening environment. I set my microphone up. Again, it's bouncing around. I'm just going to go right over here and change this back without touching anything. You can see my levels bouncing around there to about 0 dBU. Getting a little hot every now and then, but that's okay. I'm loud and boisterous. And I am, again, very conservative on my measurements. So this is a great setup for my room that I'm in right now. Not too much, not too little. I hear absolutely nothing coming from my loudspeaker. Let's do this. I'm going to do something here. Noreen, can you turn on our test microphone again? Now I have this microphone that was listening to our Piezo. You can probably hear me talking into it. There's no noise at all coming from my loudspeaker. No noise. No noise coming from my loudspeaker, but a lot of audio. Okay, so that is balancing audio systems from mic gain to amplifier settings, matching your equipment with other equipment, your microphones to your mixer, your loudspeakers to your amp. That whole system has to match your room, soup to nuts. I know this was fast and this was furious, but if you want to make sure your loud system's always going to function, this is the basis. Now, this is not the end. There's a lot more to do, but this is the basis of any audio system that you do. So, what I want to do real quick, let's take some questions. Let's see. Question from David. Doesn't the speaker load down the output so that the voltmeter is no longer accurate? Actually, what I'm doing, David, if you could see this, I'll show you the camera real quick. I have my loudspeaker being powered off the left and my voltmeter coming off the right. And that's actually not, it's not coming off of an amplifier. Those are just line loads coming out of the back of the mixer. That's line level going to the amplifier that's in my loudspeaker over there. So no, it's not weighing down the voltmeter at all. That's kind of why I do it. And your voltmeter has really, really high impedance. I mean, it barely taps that signal at all. So it's not going to weigh down the voltmeter going into the separate channels. And a lot of times I will disconnect all the channels and do everything electronically before I actually hook up into my loudspeaker. But no, to answer your question, no, that's not going to affect that at all. All right. Let's see. Kind of other questions. Jason, how many Venus do you go to that actually have systems at 0 dBu? How many Venus? Well, I was at Venus the other day, and sounds totally different because, you know, atmosphere. Venues. How many venues do I go to that have actually have systems set to 0 dBu, or actually balanced, I think is what you're meaning, Jason. Yeah, thanks for that. I don't know. I go to a lot of venues. Some of them are balanced. I know some here in the area that I do sound at. A lot of the sound guys know each other. We talk. A lot of them are members. They balance their stuff, and they're real picky about balance their stuff. House guys love to balance their stuff. We want to make sure that the venue has the right sound, that everything's working right. If your loudspeakers are underpowered for the venue, we set all this up, and we're only getting like 95 dB out of our loudspeakers, 95 dB RMS, and I measure my ambient noise in the club, and it's 75 dB. I'm going to be about 10 dB short. What that's going to do is cause me to push everything. I'll turn those amps up a little bit more, but it might cause damage to your loudspeakers. And if you're really having to push stuff, if something spikes, boom, your system's gone. If somebody gets a little crunchy, it starts hitting rails, starts overloading their channel, it's going to overload your loudspeakers, and that's just badness all the way around. So a lot of the guys are really protective of their systems around here. Most places I know where the sound guys are really good, professional houses, whatnot, the sound guys are real diligent about going through and doing this stuff. They're real diligent about making sure they have enough amplifier to power the room with headroom, that their speakers are going to give the right SPL, sound pressure level for the listening area. I was in Finland, and we were in a club called G Live Lab, and there was Genelecs all over the place and acoustic modeling, and they made sure every seat in the house was to an appropriate listening level, and everything was shielded. But the listening level was crucial. They even had speakers that acoustically modeled everything. So thank you guys very much in Finland for showing me that. It was wonderful. So I want to make sure any venue that I go to and do a test. I get there early enough just to run quick tests. The first time I go to any venue, I show up 3 to 4 hours early. If I can get in, knock on the door when they're setting up before anyone's there, make a little loud noise. The staff hate me. They'll get over it. And make sure you test the system if you haven't done it before. If you have run that system before, notate all of the positions of knobs, et cetera, et cetera. Take a look at the system before you work on it. The worst thing you can do is go in and start working on a system that you don't know what's going on with it, and you get weirdness out. So hopefully the systems work on Venus the same way they work on Earth, and we can have 0 dBu coming out of the console and appropriate amps and loudspeaker settings for our venue. And I think that's it. I think I'm about out of time. I know we went a little bit over. I want to thank you guys very much for being here. I know there's a lot of stuff to go over. We are going to post this video in a couple days so you can go back and check out all of the calculations. Again, if you have any questions, please, if you have any questions about anything on this webinar, please don't be afraid to shoot me an email, shoot me an IM, shoot me some type of message, throw me a carrier pigeon and ask. I don't want anybody to walk away having their questions unanswered. Next week, Wednesday, April 11th, we're going to have power and grounding best practices with Tom Kerr. The time will be 1 o'clock Eastern Standard Time, New York, and all the guys on the East Coast. It will be 6 p.m. in London. And again, it's free. If you want to get more information on that, you can go to https://avixxa.netexam.com.catalog.html. You know what? That's silly. Let's go to avixa.org. Click on the events tab and just scroll down and it should be right there for you. Thank you very much on behalf of everyone from Avixa. I hope you enjoyed this webinar and hopefully we'll see you next week.